intentionally picked this as a little bit more challenging problem, so let's see if Austin comes up with something else.
Just try e to the x.
Just go with e to the x, okay? E to the x, derivative of that is e to the x dx. I'm with you on that. Let's see. Where's the u in the problem for you, Austin? Where are you seeing, are you looking at this as being your u, or are you looking, could that be your u? I don't know. What are you thinking?
I was thinking the top.
Okay, so if the top here is u, right, then the derivative of it, this, needs to be somewhere. Where is it, though? Where's e to the x? You're already using this as u, right? That's your u? So where is e to the x in here?
It's down there.
It's down here?
Yeah,
Well, that's e to the 2x, though.
But it's a form of e to
It is a form of e to the x? How do you mean?
It's e to the x squared.
It's e to the x squared. That's the key to this problem. But it's still not going to work that way. You can't treat this up here as your u, because even then the derivative would be downstairs in the denominator. You don't want that. But let's just kind of rewrite the problem. Austin, take a look at this. If you rewrote this as e to the 2x is e to the x squared, because this to a power, you multiply those two, 2 times x is 2x. So that's the same problem. Now, Austin, do you see a u? Do you see your u somewhere? And do you see its derivative? And is the derivative up top?
No, it's the one.
Look at it the other way then. Reverse the way you were looking at it. Where was the u that you were looking at this as being your u, right?
Right.
Do it the other way around. Look at that as being your u. Then that's your du up here. Do you see that? That's going to work. So let's do it. I'm going to be able to rewrite e to the x dx, right? That is right here, e to the x dx. It's that piece. The 5, I'm just going to yank it out. It was just there to confuse you. All right? That 5 is not going to have any impact on the problem, right? It's going to come out. And down here is going to be replaced with 1 plus u squared. Okay, so let's do it. 5's getting yanked out. Integral. When the 5 comes out and this thing right here is going to turn into du, then I really just have a 1 left on top, don't I? And then, Austin, what do I have here on the bottom? It's going to be
1 plus u squared.
u squared, and then we said that this e to the x dx is turning into du. You recognize that? Arc tangent. Arctan. So this is the one I put the little star next to. I said you need to remember that pattern. You're going to see it again. There's arctan. So our result here is 5. I'm taking the antiderivative now, so no more integral sign. Arctangent of just u, just arctan u. And we're close.
Let me just
Replace u with e to the x, and we're done. 5 e to the u, e to the x. All right, that was a really good example. What I liked about that the most is that we were able to actually go through someone's thought process on it. You've got to be willing to try something, see that it's not going to work, try something else. That's very important here. All right, we got about 10 minutes. What I'm going to do is I'm going to pass the sign-in sheet around. Make sure I got, where was Austin? Okay, if you have a little slash mark on your name, that's because I called on you. You don't have to sign in. Everyone else, make sure you initial. All right, and while that's happening, I am going to talk about something. Your homework for this is 36 problems, numbers 1 through 36. All right, and there's a good variety of problems there. Make sure you go through and do them. I again have the videos of all the solutions there for you. And the way I look at it, I'm not good with analogies, all right? I'm terrible with analogies, but here's a good try. Like, let's say that, has anyone here like run a marathon or a little race or something before? Yes? I mean, okay, you have an idea of what a marathon is? Okay. So what I've done here today is it's kind of like we've walked the course, okay? We've walked through there. I said, look, over there, a mile in, there's like a water station, and 2 miles in, there's some bars, little power bars over there, and there's a shortcut where you can like cut through and cheat. I've tried to give you as much as I can as far as tools to prepare you for the race, but now you actually have to go run the race. And the only way you're going to get good at it, is by actually doing it, putting your feet to the ground, putting your pencil to the paper, and doing the problems. Yeah, have I stressed that enough? I feel like I have. You got to do your homework. Okay. Next section that we're going to do, I'm going to introduce you to in the last 8 minutes, and we'll see. I'll try and do this every class where I try and lead us into the next section. The next section that we're going to do in here is 6.1. We'll have all the notes on it, but it's called integration by parts. And for my Cal 1 students, this is uncharted territory. We did not get into integration by parts. I know some Cal 1 students do see it. It's rare, but they do. Any Cal 1 students see the integration by parts? You did see it? Okay. So integration by parts is a technique that we have for trying to attack certain integrals where we're trying to get around this problem where if we had something like this, multiplication between two things, we couldn't just split it, right? We could not just split that apart. And that was trouble. So we've avoided these on purpose. But we want to have a way. Integration by parts might work. It doesn't always work, okay? None of these techniques always work. So we have to have something special happening in order to use this technique. What I'm going to do with the last 6-7 minutes is first of all show you where this formula comes from, because it is a formula. And I'm going to have to go back to Cal 1 to try and motivate the idea. Let's say that I'll do it this way. Let's say I had two functions in Cal 1. I'm going to write it as u times v. Now, if you don't like that notation below it, I'll show you something else. Let's say I had f of x times g of x. All right? So I'm going to use u to represent f of x, v to represent g of x. Is that okay? If I have two things being multiplied, in Cal 1, if I said to take the derivative, right, you would do product rule, wouldn't you? Okay, so this would be u prime v plus v prime u. Maybe you learned it a little different. Maybe this one was in front of that, or you switched around. It depends on your class. But that's the way I teach my Cal 1 students. Now, in terms of the f and g, it's f prime of x times g of x plus g prime of x times f of x. So that's our product rule from Cal 1. Yeah? Now what we're going to do is we're going to try and use this to create a formula. And what I'll do to do it is I'm going to take this equation and I'm going to actually come in here and integrate it now. Find the antiderivative. So I'm going to take the antiderivative of this side, okay? And then the antiderivative of this side. How many terms are on this side? 2. When you take the antiderivative of two separate things, can you do them separately? Yes. So this is this and this, right? So I'm taking the antiderivative on both sides. What do you think this turns into? I'm taking the antiderivative of the derivative. That should just be u times v, shouldn't it? U times v? It's kind of like, hey, take the derivative and then come undo that. So you should get uv here, u times v, equals, and then over here,
U times.
these two, I have no idea what they are. I don't, right? I don't know what this is. I don't know what this is. You cannot split this into two separate ones because why? It's a product, right? You can't pull them apart. So this is where we are, and that looks like big deal, right? Like, how could that possibly help us, right? How could this possibly help us in this section of trying to figure out antiderivatives? Well, here's how it's going to help. I'm going to rewrite this same thing right here, but in terms of f and g. All right, so this would mean that f of x times g of x, right, that's u times v, is equal to integral what? So I'm doing this, right?
Integral of f
I never put the derivative on this, Mark. I apologize.
the f prime g.
F prime times g of x, right?
Yeah.
Plus
Integral
g prime
f
times f of x, yeah? Do y'all see this? I haven't really shown you anything other than there's the product rule and then I came and integrated it. All right. Now, I'm gonna take this right here. Instead of working with that one, I'm gonna take this one right here. This is an equation, right? When I have an equation, I can move things around, right? So what I'm gonna do is I'm going to choose to leave this one here and move that one to the other side. And when I do that, tell me what I would have. What would I have if I left this one here and took that one to the other side? It would be, this is equal to, right? This is equal to, so let me write that. This one right here, f of x, I'm changing the order on purpose, equals, so that's this, equals, this is still over there, right? On the left side? My left and right sides are switching places here. Minus integral f prime g, I'm going to go g of x, f prime of x. How much time do I have? 2 minutes. All right. This is an introduction, so it's all right if I leave this kind of loose here. Any questions on that? All right. Now, if you all agree that that's true, that's the integration by parts formula. And it doesn't look like it does much of anything, because what it is a formula that says, hey, guess what? If you have this integral, it's equal to this, and here's another integral. But these integrals are different, aren't they? What's the big difference between those two integrals? What's what? That's right. We switched which one had the derivative on it. Here, f, it's just f, right? But in the new integral, it's the derivative of f. Here, it's the derivative of g, and over here, it would be the antiderivative. Now, why would that be helpful? Let's see. Let me give you a problem that we couldn't do. You see that right there? Okay. We can't do that right now. But if I treat this guy right here as f of x, and I look at this one right here, everything, as being the derivative of some function, then in the new integral, right, what would my new integral have in it? According to this formula, I'm going to have f and g out here, but what would be in the new integral? It would be g of x. What's g of x? Well, that's g prime, isn't it? So what's g? Sine x. Look, I'm looking at an integral and I'm trying to identify one function as being f and the other one as being the derivative of something else. In the new integral, instead of this g prime being over here, I have g. And the antiderivative of this is g, which is sine x, right? So my new integral is going to have sine x over here times, now what's the derivative of f? 1. Right? 1 dx, actually. And look at this integral. Can you tell me what the antiderivative of sine is? Negative cosine. Now, we're going to have to spend all next class on this, but the whole idea here is that this formula allows us to transfer the derivative. Did y'all hear me? Integration by parts formula allows us to transfer the derivative from one function to the other. All right, y'all have a good weekend. Enjoy the mass quantities of substitution problems that you will be ingesting, and I'll see you on Tuesday.